All right, folks, and thanks for tuning into the Cosmology segment. Today we're going to be talking about a random quasar, overused words, me on Twitter, and how about some stuff about duct tape? Yeah, for real. First of all, we do regularly stream live to Twitch. We just actually streamed some behind-the-scenes stuff. If you haven't checked that out, twitch.tv/smAsho. We've also recently uploaded a meteorology segment. If you haven't checked that out, please do. Thanks to all you loyal subscribers on YouTube. Thanks to our new subscribers. Thanks, friends, foes, science noobs, and science pros who watch the channel. We're also on BitChute. We uploaded yesterday's Cosmology segment to that. We are counting down to the solstice. We will be streaming live for the solstice. It's Cosmology, sort of, if you're going to be loose with your terms. Don't forget to visit our own websites, smashamash.com, etc. And again, follow me on Twitter. If you haven't followed me on Twitter yet, check it out. There is exclusive content there like Instagram, only it's not Instagram, it's Twitter. So check it out. I've only got 126 followers over there. And yeah, I don't care if Twitter bans people or not. I probably won't get banned because I'm fairly rational. Now, don't take that the wrong way. And if you regularly watch our Cosmology segments, you may know that we pick random numbers on the regs. Today's random number is actually 32. I had to refresh the page. And this random object is not random, as I don't believe anything is random in the universe. And let me just rant on randomness for a minute. The term random is probably the most overused term in popular U.S. vernacular at this point in time. Think about how often random people have randomly said the random word random. It's completely overused. I think it's the most overused word that is commonly used. Especially, like, lots of people on the internet are constantly saying random. Random this and random that. I randomly did something completely not random today. I randomly decided to yada, yada, yada. What's random about that? How is it random to decide anything? It's clearly not random if you've decided something. This part of your brain, part of you had this. If you're battling over two different ideas, you're like, oh, it could be this one, it could be this one. Here's these facts, and here's these facts, and here's how there's nothing random about it. Anyway, all right, I'll stop ranting about randomness and show you this quasar. So here's this quasar, and it's we're actually looking at it in gamma ray right here. This is the gamma ray spectrum. And let me just shrink it down here. That is the Fermi gamma ray survey. So here it is on the Chandra, a little bit more high-res imagery of it on the Chandra. But you can see it is a gamma ray location. And so quasars, what's interesting about quasars, folks, is that they are galaxies where the galactic core jet is oriented directly toward you, the viewer. So I'm just going to take a moment to draw something for you here real quick. And what we're talking about here is how there is nothing random about the perspective that causes cosmological objects to appear as they do. So in this case, you're looking at a quasar, and what I'm going to do here is I'm going to draw three galaxies. And they're going to be three drawings of the same galaxy, not to scale. So first, I'm just going to draw a basic spiral. Now, not all galaxies are spirals, and not all galaxies have a coherent singular jet coming out of their polar regions, apparently. However, again, this is going to be three drawings of the same galaxy. So here's the galaxy. It's just a basic single spiral. In fact, let me redraw that entirely. Make it a little bit more galaxy-like. We'll make it a three-lobed spiral, right? If you view this galaxy edge on, it may look something like this. Like a cigar shape, kind of. And the whole thing would be sort of bright and sort of dusty, with most of the stars packed into that disk. And then if you viewed this from an in-between perspective, it might look like this, where you've got the three different spiral arms of the galaxy that are all kind of They're sort of pressed together here because you're looking at it from a different let me draw that again. Let me just get rid of this last one here. It's going to look something like that. You're viewing it, you know, from an angle so you can sort of see one of the spiral arms, and you know, if you have a full spiral viewed from the edge, it would look like a compressed spiral, where it's kind of like in this sort of a shape. Anyway, the point is, let's say the polar jets from this one are perpendicular to the galactic disk. So this galaxy may have polar jets like this, right? And if it does, from this perspective, if you're looking directly down this disk, down this jet, perpendicular to the disk, it may just appear as a very bright elliptical galaxy, and that is what a quasar basically is. So if you imagine viewing a galaxy almost edge on, but not quite, the one jet might be sort of in this orientation, and the other one might be sort of off in this orientation. And let's just draw this as a tube. If you're viewing it like this, you're going to see a quasar or a blazar. If you're viewing it like this, you may see an active galactic nucleus, a Seyfert 2 galaxy, perhaps a BL Lacertae object. And if you're viewing it from this perspective, you'll have a good view of the spiral arms because you're not right in this polar field jet region. Meanwhile, if you view a galaxy edge on like this, where it just looks like a cigar shape with a little bulge in the middle, if you see a galaxy from this perspective, it tends to be a radio galaxy because we see very high X-ray output coming out of the poles. And we see a high radio output coming out of the disk. As you're not really exposed to these polar jets, if you're viewing it from this perspective, they're sort of perpendicular to your perspective. But if you're viewing it from this perspective while you're in the jet, it makes the galaxy appear completely different, much brighter in X-ray, and often radio quiet, but sometimes you see full spectrum as well when viewing active galactic nuclei. And I'll just leave all active galactic nuclei in one category, as that includes Seyfert 1s, Seyfert 2s, quasars, blazars, BL Lacertae objects, and AGNs, active galactic nuclei. In other words, galaxies where the core looks exceptionally brighter than the rest of the galaxy. Here are the X-ray outputs from this particular quasar that we were looking at, 4C01.02. So this must be a very early discovered quasar based on the naming convention. And we'll just go back and show you some more visual analysis of this. So now we're back on the Aladdin light, and this is the optical band. This is a pretty high res view of it. Let's see if it shows up on Pan-STARRS as well. An even higher res view of it there on Pan-STARR. Great imagery there. This also does show up on the 2MASS. There is the infrared radio spectrum, the infrared light spectrum. So just it's heat, essentially. For all intents and purposes, that's the heat portion of the electromagnetic spectrum. And we'll also show you red and blue. There's blue light. And here's red light. You may see some differences there in the spectra, and you should. It does not show up in hydrogen alpha. But anyway, there it is once again on the Chandra. And this extended region of X-ray is probably an indication maybe of the opposing jet. Maybe this is almost not directed, directly at the Earth system. Maybe this is sort of a little bit skewed, and one of the jets is directed away from us. Or perhaps there's a big bend in the jet, but for whatever reason, from our perspective, we see this bright region right here with extended X-ray output. So perhaps an interesting one for further study. I'd like to see this on a detailed radioscope image. And if anybody looks that up, leave us a comment if I don't do it myself. Next, let's talk duct tape. Don't leave home without it. And in 1972, on Apollo 17, they didn't leave home without it. Check it out. They fixed the fender on their lunar rover with duct tape and some maps. Why? Because as they were driving around, this thing was creating a rooster tail of lunar regolith, and they were getting dust all over themselves and their equipment. And that is a big no-no, folks. That's a bunch of glass particles up there. You don't want that lunar regolith in all of your gear. So they extended their fender, I guess. Or I don't know if it broke. Hold on. Let me read this. Harrison Schmitt and Eugene Cernan needed to repair one of their rover's fenders in order to keep the rooster tails of dust away from themselves and their gear. And check out the rear wheel. It's like made of a hollow metal mesh. It must fold to be flat and then unfold to be shaped like a tire. They use some spare maps, some clamps, and check it out. Right there. Duct tape. Duct tape. It fixes all of your woes, folks. It even fixes the fender on a lunar lander. Yes, glue. It works in space. And that's today's Cosmology segment. We wanted to keep it short because the meteorology segment's pretty exciting. If you didn't check that out, please do so. I've been your host, Dan, a.k.a. smAsho, here at the Smash News Network, least busted name in news.